Okay, good evening to you all. Until others are joining, we'll start today's lesson. Before going to today's lesson, according to your comments from me personally, and I thought of doing a small revision on statistics part because according to your comments, some of you are confused about this mathematics because there are so many mathematical formulas and all. So to reduce it, I hope to give you a small revision on uh, statistical part. And also we have two more lectures. Without today, we have two more lectures. From there, we have to stop this course unit. So I hope to discuss you according to your request. I hope to discuss uh, two or more model papers with you because we can conclude our theory parts from next session. Half of the next session we can conclude it. So then we can discuss questions. And today also I hope to discuss some questions. So I think that will be fine for you. And also I upload presentations and notes for your WhatsApp group as well as to the LMS. Then in both ways you can take notes. Okay, still there are 17. Before going to this part, we started statistical part from here. Before going to that, so from the first session, we discussed about measurements and evaluation methods, assessment methods, basic methods. Then we discussed about the quality of the paper. Under quality of the paper, we talked about the validity, then reliability, and also the difficulty indexes, item discriminations. Those are the things we considered about the quality of the paper. Finally, we discussed that about the face validity. That is not the big concept, but face validity is very, very important for the paper. So we discussed those things in order to give or produce a quality paper to the children or to the candidates. Without that quality paper, we can't use any evaluation methods. Because that is not fair, no? Therefore, we have to, first step is we have to produce the quality paper. After producing quality paper, we have to distribute it among the relevant group of children, and then they answer the questions. Thereafter, we evaluate it. We have to evaluate it. When evaluating, we have to maintain the validity and reliability of the evaluation process also. Thereafter, we can publish the results of the students, even in national exam or in normal classroom test or term test or anything. Those are the steps. Now we are at that point. Now we discuss how to produce a quality paper and how to evaluate the papers by maintaining reliability and validity. Then now we have the marks. Now we have the marks of the children. So within those marks, as teachers, as as other persons like principals or divisional secretariats or SLTES or SLEAS officers. Sometimes they have to know the growth of our results or something, anything. To do that, we have to go for some type of calculations. That is the aim of discussing descriptive statistics here. As I told you, in statistics, there are two parts, descriptive statistics and inferential statistics. So, up to now, we discuss about descriptive statistics in detail. And from next session, I hope to discuss something about inferential, not in deep. So, that's all. So, in descriptive statistics, we discuss these things. There are three parts: frequency distribution, central tendency measures, and measures of dispersion. So, frequency distribution is the main stage or the foundation. That's why in the first part, as the first part, we discussed about frequency distribution. Based on that, we elaborate on that some mean, median, mode, and dispersion methods. We can describe others using this frequency distribution. So, when we talk about the frequency distribution, we discuss about ranking methods. When discussing about ranking or finding the cumulative frequency or anything, we went step by step. First, we discuss about small number of items. Then we went to about 50 scores. Then more than 50, 100, like that, we have to go for frequency distribution tables. So likewise, we discuss step by step. So this is how to rank the raw scores. And then if there are more than 20 items, we have to go for this type of table. Their mark is X and F is frequency. Then if the number of data points are more than 50, we have to go for class intervals. When using class intervals, usually you mean the class intervals like 5 to 10, then not 10 to 15, but 11 to 16. Those are the class intervals most probably you may mean. Then, if the class intervals are like that, there is a gap between class intervals. To fill that gap, we have to go for real limits. So, to find the real limit, we have to add 0.5 for the upper limit and subtract 0.5 from the lower limit. Then, how to find the midpoint? When we use the class intervals, definitely we have to go for midpoints because we use the midpoint as X values for our calculations in class intervals. We discussed about that in the last session. So then the range, to find the range using maximum and minimum value, we have to add 1. If we use limits, no need to add 1. So then we discuss about how to find the number of class intervals, how to find the range, then how to find the lowest class interval. There is a law and the rule. According to the law and the rule, we have to define that. Then using the class intervals, we have to define cumulative frequency and percentage frequency distribution. to make that table, we have to arrange our data into a low ascending or descending order. Most probably we use ascending order. Then we have to find the highest value, then lowest value, and take the range. And then we have to decide what would be the width. Then we can decide the number of class intervals by dividing the range from the width. We have to take it for the nearest higher integer. Then we have to define lowest class interval according to the rule and the law. So by using these steps, we finally discuss about this table. So if you are given the question from class intervals, step by step, you have to first you have to decide according to the given data set. You have to decide what should I do if I go. Is it with class intervals or only using the frequency? Like that, you have to decide according to the range and all things. Then, if you decided to do it using class intervals, you have to put the frequency column. Before frequency column, now we discussed from our last lecture, I told you to take the mid value of the class interval as x. Because when we put frequencies like that, as example, from 50 to 54, there are only 6 students. It means 50 to 54, it means 51, 52, like that. There are 60 students. But we don't know the exact value of that. But when calculating mean value, we have to have the exact value of that particular frequency. Therefore, we have to go for mean value. Don't confuse. To find the mid value, we have to consider class intervals, not frequency. From the class interval 50 to 54, to find the mid value, we have to add both 50 plus 54 divided by 2. Or you can write 50, 51, 52, 53, 54. There you can see 5 numbers are there. So the mid value is 52. Like that, you have to mention the mid value and put it as x, not the class intervals as x. Then frequency. Then another question is cumulative frequency. To find the cumulative frequency means you have to add the frequencies from lowest value to upper values. Here, the lowest class interval is 1. So you have to put 1, same 1 here. Then add 1 plus 4, 5. 5 plus 5, 10. 10 plus 6, 16. Likewise, for the last cumulative frequency should equal to the number of data points here. Then percentage. Find the percentage, you have to consider the frequency. So the total number of data points are 40. 40 upon 6 into 100. 6 by 40 into 100. Value is 50. Like that, you can go for percentages. If the percentage value is for decimal points, better to keep it for 1 decimal point, nearest decimal point. Then again, cumulative percentage frequency. That is, cumulative percentage frequency is same way like we find the cumulative frequency. Likewise, so the percentage value of last class interval is 2.5. Then you have to add 10 for 2.5, that is 12.5. 12.5 plus 12.5, 25. 25 plus 40, 15, 40. Likewise. So most probably the final cumulative percentage frequency should be 100 or near to 100. So then, yes, those are the things we discuss about frequency distribution. Then, the last session. There we finish our descriptive statistics part. There we discuss about central tendency measures and measures of dispersion. Under central tendency measures, mean, mood, and median. So mean also, there are several types of mean values. From there, we consider about arithmetic mean. When finding mean, median, or mode, we have to we discuss we discuss those things from 3 steps. Those are finding the mean or median or mode from the unorganized data set, then from frequency distribution, and from frequency distribution with class intervals. So mean is the in the simple way, mean is the average. So there we have to add all things and divide number of students. It's like you how you find the average marks of the students in the class. In the report cards, to put in the report cards. So then if the data points are more than 20, we go to frequency distribution like this. Here also I told you F and Fx. So then addition of Fx divided by number of data points. Then if the data points are more than 50, we have to go for class intervals. There we have to use mid value as I told you earlier. Class intervals, real limits, then mid value. So 80 to 84, mid value is 82. Like that. So mid value is considered as x, and it is like fx. Then we have to multiply mid value and f value. Then take the addition of that and divide by number of data points. We discussed that if the number of frequency or the mid value is highest value, then the calculation is much more difficult. Here, as sigma fxc, we can have the large number here. So divide the large number by the large number of data points. It is much more difficult. Therefore, we have to go for assumed mean value. If it is difficult for you to use assumed mean value, no problem. You can use only frequency and midpoint values. If the simplification is not too difficult for you, it's okay. No need to go for assumed mean value. Actually, that depends on the data set. So assumed mean value is taken as capital A, then X is the mid value. Then we have to find the difference between the assumed mean value and the other mid values and divide by the class width. Hence, we have another 2 columns there. See, from those class intervals, we have to select the class, any required class interval and that row as mean class interval. For that, usually we have to take the mid value, mid classes. Don't take upper classes or lower classes as assumed mean values, because according to your knowledge, if there are some scale values, there may be differences. Therefore, don't go for lowest class intervals and lowest class intervals and higher class intervals. If there are outliers in our data set, that will be a big effect for our answer. So better to select any class interval in the middle. Here, they considered 62. It means 60 to 64 class interval and 62 as the assumed mean value. Here we assume 62 will be the mean. That's it. Then the class interval is 5, and one by one we have to calculate the d value. This means the deviation. Here 62 deviation is 0. It's there. Then 67 minus 62, 5. 5 divided by 5, 1. 72 minus 62, 10. 10 divided by class with 5, 2. Like that, minus value 47, 62 minus 47 minus 62. Divide by 5. Then you can have minus 3 answer. Like that, you have to find d value. Don't exchange those things. D value is calculated from this mid value, not from frequencies. By looking at someone's answers, sometimes you may mix up those things. Don't consider the assumed mean value is here 62, not 8. 8 is the frequency. If it is confused for you, you can arrange the columns like this. Class interval, then mid value, and then d value. Take d value here. Then mark F, and then FD. You can interchange those columns. Anyway, no need to rigid for this type of arrangement. You can use it in any way. Then sigma FD. So we have to go for, then you can substitute these values for this equation. X bar equal I sigma FD divided by n plus A. This is minus 0.19. So 62 minus 0.19 becomes 61.81. That is the way of finding mean values. Is it clear for you? Now, are there any questions? Please ask. It is your chance. Don't hesitate. Ask any question. So at the end of the last session, I gave you an exercise and I told you if you want, you can send it to me. Yes.
Ma'am, can you send this presentation for us? End of the session.
Oh, I sent it now.
Okay, ma'am. Sorry, ma'am. The last one I did not get that side.
I put it into your WhatsApp group.
Okay, ma'am. Okay, thank you.
So then only two students sent me the answers and then I corrected them. So that is a very good trend actually. So if you don't have any questions, we can move on to the median. So median is the mid value. So if the number of data points are odd value are odd, then you can find the mid value. To find the mid value, if the number of data points are 11, assume that 11, then you can take you can add 11 plus 1 divide by 2. That is 11 plus 1, 12. 12 divided by 2 is 6. So 6 value is your median. Here the data set is here. So then first you have to arrange them in ascending or descending order. Then you can find the mid value. If the number of items are even, there you have to have two mid values. Then take the average of that. If the number of data points are lower than 20, manually you can do it. But if the data points are more than that, you have to go for this. If the number of data points are even values, then here the example is 50. 50 is even value now. Then divide 50 by 2, that is 25. Then 25 plus 1, 26th place. So here you have to find 25th place value and 26th place value. Then take these two values and add up those two values and divide by 2. That is the way. If the number of items are odd, here also you have to add 1. If the data points are 49, then add 1, then it becomes 50. So definitely the mid value is 25. No need to go for 26th value. So after finding the place of the mid value or median, then we have to go for cumulative frequency. By interpreting the if I interpret the cumulative frequency here the 16 means there are 16 students who took 5 or lower than 5 marks. There are 16 students. Here 31 means up to 16 there are students who took 5 or less than 5 marks. Here 31 means there are 31 students who took 6 or less than 6 marks. Here 16 up to 16 there are up to 16 students there are only 5 marks. Then up to 31 students there are 6 or below marks. So here we need 26th place value and 26th place value. You can see that 25 and 26 places are inside this column now. Up to 16, it is below 5. Up to 31, there is 6. Below 6. So, 16th student took 5 marks. Then 17th student took 6 marks. 18th student also 6. 19, 6. 26, 21, 22, up to 31, 6 marks are there. Therefore, now you can understand that 25th place and 26th place are there. They are within 6. So, the 25th value is 6, 26th value is 6, 6 by 6, 6 plus 6, 12, 12 divided by 2, again 6, median value is 6. That is why we need cumulative frequency here. If we use class intervals, there we have to use this equation. Now, by looking at this, you have to understand these notations. L is the lower limit of the median class. N is the number of data points. Simple F is frequency for the median class. I is the width of the class. And capital F is the cumulative frequency, not of the median class, but cumulative frequency of the class which is lower than the median class. Don't mix up those things. I told you the better method is you can write those equations into a separate paper and then do exercises by looking at these things. This is how we calculate the median value in the class interval. So the total number of data points are 8, you can see. So the mid value is 40 and 41. So here up to 33, then 33 students got below 55 marks, below 59 marks. 41 students got below 64 marks. Therefore, we need 40th place and 41st place. So it is included in this class. That is why we consider it N. The L is the lowest limit of the median class, that is 60, 60 minus 0.5, 59.5. So 80 by 2 minus cumulative frequency of the lower class. It is 33. Divide by the frequency of that median class, 8 into class with 5. There you can calculate median value. Are there any questions on median? Finding the median value. Okay, then mood. Mood is the most common number in the class in the data set. There, if for small set of numbers, you can find by looking at them, you can find the most common value. There may be more than one most common number, so it has multiple moods. Better to arrange them in ascending or descending order first, then easily you can catch up the most common value. If you go to frequency distribution, by looking at the frequency, you can see the highest frequency is the common value. So here the highest frequency is 15, so the mood is 12. If you go for class intervals, I told you we have to use histogram. Or there are two methods, using histogram or finding the value using the formula. So by looking at the frequency column, we can find the mood class. Not mood class, we have to find the mood value. To find the value, correct value, we have to go for these methods. If you draw the histogram using real class intervals and frequencies, you can have the bar graphs like this. Then by looking at those pillars, you can see the highest pillar is the most common pillar, common value. So then mark the lines like this. That is the lower real limit of the mood class and the lower real limit of the upper class. You have to combine. You have to combine. Then the upper class limit of the upper real limit of the mood class and the upper real limit of the class which is lower than the mood class, and then connect. By connecting those two corners, then there is a point which is intercept each other. So draw a vertical line downward to the x-axis. Then you can find the mood. To do that, you have to have the graph paper. If not, you can use this equation. L plus delta 1 divided by delta 1 plus delta 2 into I. L, anywhere, L is the, in statistics, L is the lowest class limit of the, real lower class limit of the mood class. If it is for median, that is lower class limit of the median class, like that. Then I is the class width anywhere. Then delta 1 is the frequency, difference of frequencies between the mood class and the lower class. Here, the mood class is 12, the lower class is 10. So the difference is 2. Delta 2 is the frequency difference between the mood class and the upper class. That is 7 and 12. Difference is 5. No need to take plus and minuses here. We need only the difference. That is why delta here. So no need to put minus 5 or like that. Just take the difference. Then calculate it like this. These are the central tendency measures. Central tendency measures means we find we discuss about how to find the distribution of the data set around the mid value. That is central tendency measures.
Excuse me, madam. How did you get that delta 1 and delta 2?
That is formula, the standard formula to find the mood in the class intervals. No need to go for definitions. This is, we have, if you want to find the mood of the class intervals, then you have to use this equation.
Okay, madam. Delta 2, which goes for value number 2, and delta 1, which goes value for number 2, and delta 2, number 5. How did you get that, madam?
Yes. Delta 1 is the difference of frequencies of the mood class and the lower class to the mood class, not median, mood class. So the difference of frequencies of the mood class and the lower class. Here the frequency of the mood class is 12 now. So the lower class is 65 to 69. This is the mood class. So below that the class is 65 to 69. So its frequency is 10. Then the difference of 10 and 12 is 2. That is delta 1. Then delta 2, difference of frequencies of the mood class and the upper class. here the mood class is 70 to 74. Then the upper class is 77 to 79. Its frequency is 7. So the difference of 12 and 7 is 5. Understood?
Okay, madam. Thank you. Got it.
So here we discuss about where we can use mean. That is mean gives the average value, and that is actually that is a good value. But if there are outliers, we can't use it. If there are outliers, we can use median. When finding the median, we consider only the mid value. There we don't calculate about the outliers. So if there are outliers, median is the suitable one. Then mood, it can be calculated easily, but it is not a good method. But if you want to get the idea quickly, it is suitable. Then we went to measures of dispersion. Under central tendency, we discuss about the normal values, how they spread around the mid value. But in dispersion, there we describe about how the data points spread or how they vary. So we are going to take that idea. Range, to find the range, we discussed this also. But range is not the good measurement, because if there are outliers, our answer will be totally different. Therefore, don't consider range if there are outliers. So, to minimize the errors in the range, we can use interquartile range. In interquartile range, first we have to arrange the data set into ascending or descending order. Then we divide the data set into four parts by using 3 quartiles. Quartile means 4. It means by using 3 quartiles, we have to use the total range into 4 parts. Using these parts, using these values, we divide the data set into 4 parts. Now that is why it's called quartile. So Q2, Q1, Q2, Q3 are the quartiles. So in the Q1, if you arrange your data set in ascending order, so the minimum value, you have to start from minimum value and end from maximum value. If it is there, as Q1, we have to consider the 25th. It means from the data set, we have to find the 25% from the lowest data. Or there, if the number of data points are n plus 1 divided by 4. That is Q1. So Q2, there you divide your data set into 2 parts, so 50% are there. It is like similar to finding the median. Then for Q3, you have to consider 75% from the lowest value. That is n plus 1 into 3 by 4. 3/4 of n plus 1th value. So interquartile range is Q3 minus Q1. There also we can omit the outliers. Only we consider these the data points from Q1 to Q3. We omit the latter parts. That is why if there are outliers, interquartile range is better. These are the examples we did. If the number of data points are more than 20, we have to go for this 50. So the total frequency is 50. 50 divided by 4 is 12.5. 12.5 from the cumulative frequency up to 10 here. There are 10 students who took 4 marks or below 4 marks. There are 16 students who took 5 or below 5 marks. So then 12.5 fifth point is included in this row. Therefore, Q1 is here. Q1 value should be 5. Likewise, Q2 is 25th and 26th one. Also, it is included here. So, that value is 6. So, 3/4 of 50th value is 37.5. That is here. So, it is 7. Yes.
Madam, if we find median, do we need to find the Q2 also?
I can't hear you. Can you repeat
If
it
we
again?
find the median, we can find the median now, madam. Median.
Hmm.
If we find the median, do we need to find again the Q2?
No, no, no. No need.
Mm.
If you ask the questions from here, step by step, they will ask you, first you have to find the mid values, then find the median, mean, median, then find quartiles. Usually, don't ask find quartiles. You may ask find interquartile range. There, you have to find only Q1 and Q3. And take the difference of that.
Okay.
Okay. Like that, better to ask questions. Then only I can verify your understanding. So, if we use class intervals, we have to go for this type of equations. It is similar to finding median. When finding median, L is the lowest limit of the median class. Likewise, when finding Q1, L1 is the lowest limit of the lower limit of the Q1 class. L3 is also like that. Here F is the cumulative frequency of the class which is lower than the median class. That is also the cumulative frequency of the lower class which is from the Q1 class. Likewise, F is the frequency of the median class. Here F is the frequency of the Q1 class. Don't mix up. Try to understand the similarity. Then it will be easy for you. This is how we found the Q1 and Q3 values here and find interquartile range. Here Q1, total number is 40. So 40 divided by 4 is 20. 20 is included. Sorry, 40 divided by 4 is 10. 10 is included here now. So this is the Q1 class, 50 to 54. So the lower class limit is 49.5. And the cumulative frequency of the class which is lower than Q1 is 9 here. And the frequency of the Q1 class is 8. When substituting, be careful, don't mix up. Then it is similar here. So Q3, that is 30th value. 30th value is here. 60 to 64. So the lowest class limit is 59.5 and cumulative frequencies of that class is 6 and into 5. So then, are there any other questions regarding this or up to this? So then we went to standard deviation. That is the measure of dispersion of statistical data. There we have to use if you search the internet, you can have several equations. For our convenience, it's better to use this equation only. S equal square root within square root sigma x square divided by n minus sigma x over n total square. Better to use this. Here no need to find the mean value, and also this equation comes from this equation. Sigma within square root sigma x minus x bar square divided by n. It is also not difficult. If we use this equation, it is also okay. By expanding this equation, you can get this equation. No need to find how to expand this and all. You need only the equation. Here the x value is here. You have to find the mean value first. Then find the deviation from the mean value from the x values. Then compare them.
කැමති වෙන්නේ නැහැ ඉන්න. දෙන්න තිබුණ නැති එක නෙමෙයි මට මතක් වුණේවත් නැහැ. මතක් වුණා නම් මගෙන් අහනවා. නැත්තම් දැනගන්න.
Mike.
කිව්වා කඩේ බිල ගෙවන්න තියෙන ඉන්ද්‍රාණිගේ සල්ලි දෙන්න තියෙනවා බෝ. කිව්වේ නැහැ. කිව්වේ නෑලු.
Nalika, please mute your mic. Yes, Afras, ma'am, if the exam yes, you will have the questions like find the correlations and moods. That's why I decided to discuss some model questions with you. Then you can verify those things. So the main thing is you don't have the idea how to answer the questions, how to match these things to the questions. So then I will clarify it within the next 2 sessions.
Excuse me, ma'am. I am really very sorry, ma'am. I am still my 2 children small.
It's okay.
That's
It's okay. It's
very
okay.
sorry.
It's a common mistake in 2 meetings. It's okay. These are virtual classes. Now we can understand the situations.
Thank you, ma'am.
So without your sensation, sometimes your phone or mic may on. That's right. Okay. If the frequency distribution is there, we have to go for fx values. Means frequency distribution and fx values. If we use, that depends on the equation you use. If you use this equation, you have to find x square value also. X value, x square value, then fx value. And also fx squared value. It means x squared value should multiply it by f values again. Don't mix them up. Here, the square mark is for whole expression. Sigma fx divided by n total square. Don't mix it up. Here, sigma fx squared divided by n. fx squared values are here, no? 3018 divided by n. N is 20. Here, sigma fx values are here. 244 divided by 20. Then you have to square that value. That is why I told you better to write those equations correctly in separate paper. Then you can identify what are the needed columns in my frequency distribution. Then if the mid class intervals are there, you have to go for deviation. Assumed mean value and the deviation values. Then when you find d values, you have to square them according to this equation, d squared. Then find fd values, fd squared values and substitute it. Okay, it is here. This sum is without assume mean. Without assume mean, if it is difficult for you, you can do the sums like this. The thing is here you can have the large numbers there. If you don't confuse, you can use it. It's okay. If you are convenienced with this, if you are okay with d values, you can use this equation. Then variance is the square of standard deviation. I told you if you have already found the standard deviation, then you can write variance equals square of standard deviation and just square that value. No need to go step by step and similarize again. So then I gave you this question and some of you did it. So then those are the things we discussed up to now. Are there any questions you can ask before going to today's lesson? So these are the major parts. So hereafter, there are some normal things, not harder than this. Harder like this. Or finding the correlations. Hard means the only thing is mathematical equations are there. That's why.
Ma'am, excuse me.
Yes.
In the exam, do we
Yes,
have to, are they asking particularly, do we have to find the answers using the equation or the chart method? Or both ways can we find the answers?
That depends on the question. We'll discuss about that. That depends on the equation question you are given. Most probably you may have the frequency distribution chart table. Otherwise, so that the other method is very easy, no? So then
Equation.
better to prepare with frequency distribution table, especially with class intervals. But for okay, for small questions, sometimes you have to decide from the normal way.
Okay, ma'am. Thank you.
Okay.
Excuse me, madam.
Yes.
Madam, when we find the square root, is it okay with
Yes.
not the exact decimal point answers? That means we find the square root for 2511.5 like that. We can get the answer like 50.1 like that. No? So some decimal points missing. Is it okay for the?
I'm
If we
not
find the
clear.
answer,
Can you ask it again?
when we
Yes.
find the square root, madam, sometimes we can't
Yes.
find the exact value. Is it okay with the approximate value?
Yes. Yes, then you can round off it to near 2 decimal points. That's enough.
Okay.
You are allowed to use calculators, so it will be easy for you. So according to this comment, I want to tell you that there are all island students here, no? So then there are some more disadvantages in online classes, no? So, but there is no other method to do that because it is very difficult to get you in one class because of this distance. If you can visit the campus and do, it's better. That's the better thing. So I would like to give you a small idea. That's my from my own experiences. Um, do you have unofficial WhatsApp group from among you among this course?
Yes, ma'am.
Yes. Yes or no?
Yes, we have. Yes, we have.
Yes. That's the best method. Then within that group, you can share your ideas and also regarding some questions on each and every subjects. And also you can have discussion, Zoom meeting discussions. You can arrange among you Zoom meeting discussions. First, you have to decide within the group. You have to decide what is the topic we have to discuss today, and then all of you can revise them, and then discuss among the Zoom session among you. That is the very good method. So try to adapt all the candidates into that group, and that is the best method. So that will be very important and very beneficial for you if you continue your studies and get other vacancies. And all island vacancies are there. Some of you may trying to move from teaching, you want to go away from teaching, and there are so many things. So better to keep in touch with those things, all of you. Exchange your ideas. That is, if it works properly, then you will feel very comfortable with this course. As adult learners, yes, very good. If you plan it very good, as adult learners, it is not possible to take the book and read and do the things. No, we don't have time actually. Therefore, that is the best method. So try to by using those methods, we can reduce that limit. Actually, we will meet only for the convocation. We all are virtual. You all are virtual friends. So what to do? That is the thing. So better to take this type of question and do it among with yourselves. You can do it and discuss among each another. Then you can identify what are the errors, how, and all the things. Not only for this subject, all the subjects. So if you have already done it, it's very good. So let's move on to today's topic. Please give me 1 minute. I didn't open that. Okay, then. So today is our ninth session. Because of the revision, we don't have time to cover all the things, but try to do something and then we can continue from next session. So today we are going to talk about comparison and combination of scores and translation of scores. Translation of scores is our last topic. So the 12th topic is normal probability curve, and we will discuss it in next session. So comparison and combination of scores. So as I told you in the earlier, comparison and combination of scores, that is up to now we produce a quality paper and then we distribute it among the children and we evaluate them, and now we are at the step of comparison, combination, and we want to get some information using those results. That is why we discuss these things, comparison and combination of scores. Under that, we can discuss about this introduction and these things. So that is here. As teachers, you are interested to find how the scores of my children are deviate from what is the how about their performances, what are their grades. Actually, you want to know who are the students who are in minor grades, so what to do, for what are the remedies I can use then. So those are the things. Using for that, we have to compare and combine scores. So as example, the raw scores means normal data. Without doing any calculation, the data are called raw scores or raw data. So 30 from on one test and raw score for 125 for another test don't mean the same. It means, as example, you know, for science, maths, English, you for a week, students have 5 periods for a week. But for citizenship educations, they have only 2 periods. And for aesthetic subjects, they have, I think, 3 periods. So, but finally, they all face to one paper which scores from 100. So, is it fair when we consider, if assume that the student A got 65 marks for mathematics and he got 90 marks for citizenship education. So it is fair if we get the decision like this. This student is not good for maths, but he is good for other aesthetic subjects. Is it fair, that decision? What do you think? Is it a good decision? What do you think? Normally we do it by looking at the report cards and all, but that is not a good thing. Good method to compare the students. If we compare within the same subject, that is okay. If one student got 90 marks for citizenship education and the other student got 70 marks, we can say that one first student is good for citizenship education subject. But if we compare among subjects, that is not fair. That's why we have to go for fair methods to compare and combine the scores. Now we know actually when we consider the performances of the students, they never show the same developments. And also if there are developments, there may be some other extra effects like background disturbances or the illness or like that. There are some other disturbances. Therefore, we have to careful about comparing those scores. And also different students show different performances. So most probably we use finding the cumulative percentage and compare them. But there are some methods we can do more fairly. We are going to consider about that. That is called standard score. Standard score comes from standard normal table or normal probability curve. Still we didn't do that. We will do it in the next session. For your convenience, this is the normal probability curve that is like a bell shape. It contains only the mean value. Mu is for mean value and sigma. Here sigma is for standard deviation. It considered only mean value and standard deviation values. Then based on this curve, no need to go to this curve. Based on this curve, they introduce Z score. Z score is not like the Z score for the university entrance. That is not. This is X mark, Z mark. That is called Z score. That is known as standard score. It indicates how many standard deviation is the value from the mean. Z score tells us how many standard deviations someone is above or below the mean. It means to find the Z score, we use this formula. Z equal X minus X bar divided by S. Here to find Z value, we need mean value and also standard deviation value. And the particular value is here. Assume for the mathematics, student A took 70 marks. Then we have to consider his performance regarding the mean and standard deviation of the marks. Then we can put 70 marks here. Then standard deviation mark here and the mean value here. You can understand it using this example. So likewise, we can find the Z value. If we find Z value, we can have decimal values and like that. Then, according to that Z value, we can identify where the student is. If we get 0.5 minus 0.5, it means the student is here. If we get 2.5, it means the student is here. It means that student is away from the other students. Means his performance is good, but that is not the normal performance. Usually the whole class performance of the whole class is around this. So likewise, we can get the idea. Actually, now there are so many packages. Packages means softwares. You can calculate them automatically. The only thing is you have to enter the data. By entering data, you can get all these values at once. Like Excel. Excel is the primary example, but there are some other packages. But to deal with those packages in future, you have to have this basic idea. That is why these are very important, because you have to have the idea how to deal with those numbers. If you have that idea, you will be very strong. So here, the example, assume that we give the same Sinhala paper to the whole 9 section students. Then we collect their papers and randomly we select 10 papers. 10 papers and another 10 papers. So there are two paper packs with 10 papers. Randomly we select them. And we you are going to give them one pack to evaluate for Mr. Suniman. He is a sir. He is a teacher. And another pack to Mr. Jayamal. So after some times, they will give us the evaluated papers. So then from Sunimal's, there are total of 10 papers, and from Jayamal's also 10. By getting those Sunimal's values, Sunimal's paper values, there are 10 marks. By taking the mean value of 10 marks, it means add up all the values of the 10 students and divide by 10. Then the value will be 69.5. And then by calculating the standard deviation, we can get the answer 18.2. To find the standard deviation, we want that table. Using that table and all the things, you can find standard deviation. So those values are here. Similarly, we can do the same thing for Mr. Jayamal's paper pack. But we can see there are some differences now in the mean value and the standard deviation values. There are some differences. But you know, there is no, by just looking at the method we distribute the papers and all the things, there is no reason to have the deviation like this. Therefore, to clarify that, we can find Z score of those values. There, randomly you can select one paper from Mr. Sunimal's pack and one paper from Mr. Jayamal's pack. That is here. According to that selected paper, Mr. Sunimal gave 80 marks for Suranga. So Suranga is in Sunimal's pack. So from Jayamal's pack, Eranga got 70 marks. Now we have 2 row marks from Mr. Sunimal's 80 marks and from Mr. Jayamal's 70 marks. By looking at this raw data, we can see that Sunimal is better than Eranga. That is the primary idea we can get by looking at these raw marks. But as a teacher, you want to have the better understanding of the situation of these marks. Then, more fairly, you can compare this Suranga's 80 marks with that 10 papers normal distribution and mean value. And Eranga 70 marks with his 10 with his group's mean value and standard deviation value. So that is very fair. Now here we compare the performance of one child within that group. So this is how we convert it. Z equal x minus x bar divided by SD. So Suranga 80 minus 69.5 divided by 18.2. So answer is 0.57. For Eranga's mark, that is 70 minus 58.4 divided by 15.9. Answer is 0.72. So two answers are 0.57 and 0.72. So by looking at the Z value, we can see that Eranga's performances are better than Suranga's performances. But if we take the decision by looking at the raw data like this, that is not fair. That is why we as educationists, we have to go for the comparison methods like this. It means sometimes Eranga's, if we select randomly, sometimes Eranga's group may have so many performances, lower performances than Suranga's group. So according to that Eranga's group, his performances are better than Suranga's one. So Suranga's group may be different from that. So that is fair method. Is it clear for you? What do you think? Then, comparison of squares with different scales. We discuss it now. It means there are scores with different scales. So it is not fair to compare them. If you want to compare them, we have to take them into one scale. So as example, if we compare as I told you, 70 marks for mathematics and 90 marks for civics education, that is not fair. To compare them, we have to take them to the common range, common scale. So to do that, there are three methods. If the total different scales are x and y, we can convert the score of x into y scale, or convert the scores of y into x scale. Or then we can convert both scales into the external scale like Z score. So sometimes we have to keep some weights for calculating scores of the students. So the best example is Z score in university entrance. So you know, there are 5 streams now in A levels. So I don't have idea about arts. If in the commerce stream, students, if they get I don't know is it correct or not. If they get high marks for accounts, they can have the higher ESET score. In science students, in physical science, it means mathematics students, they can score more if they get more marks for chemistry. For bio students, they can score more if they can get more marks for physics. Like that. There are some different weightages. It is like the credits of your subjects. So this is 4 credits to subject. No, assume that for educational measurements, you can if you take 80 marks, so weight is 4. Credit means weight. Weight is 4. So to calculate the GPA finally, according to the GPA, you can have first classes, second classes, or distinctions like that. No. So they calculate normally. We calculate GPA by weighting according to our credits. So this course, measurements and evaluation, it is 4 credit. If you take 80 marks, 80 into 4, it becomes 240 here. If it is philosophy and I don't know, if it is 3 credits, if you take 80 marks, 80 into 3, $240. So the upper one is 320, no? Like that. By multiplying them and add up all things, you can have the sigma WX value. And divide by sigma W, total credits. Total credits. So if you know the marks or if you plan, so this is the, you can plan now your GPA. So please put your subjects here and weight credits here. Then add up all the credits. Then plan your GPA. You can plan your class. So put your plan mark for particular subjects and multiply them and find the weighted average. The weighted average means your GPA value. If the course outline is there, it means booklet is there, you can find how they give first classes above GPA, how normally above 4 you can have above 3 or 3.5. I don't know. I don't have idea. So that will, depends on the credits and the university. So you can have your GPA and your class. This is the example in Sinhala. This student got 70 marks and weight is 1.5. So by multiplying that is 105. Mathematics 65 into 2, 130. History 85, credit 1, so 85. Civics education 90, 0.5, that is 45. By adding up all those things, that is 365 divided by 5, 73, weighted mean. That is also average, but weighted average. So ESET score is also similar to this. So when given ESET scores, if we give same ESET score for whole island, that is not fair also. There are so many areas we have to consider. That is not fair, no? In the Colombo area, they have so many tuition classes and so many facilities. So, and also in rural area, they don't have such facilities. If in the Corona pandemic, during the Corona pandemic also, they don't have facilities to join online. They don't have signals. If they have facilities, they don't have signals in Sri Lanka. So it is not fair to compare all whole island students at once. Therefore, district wise, they give ESET score And also in scholarship examination also, district-wise, they give cut-off marks. That is why. And also for university entrance cut-off marks also depend on that district-wise performances. So by using all those things, we have to try to give the fair result. That's it. So those are the things I want to discuss from unit 11, 11th lesson. These are the methods of compare and combine scores. Then translation of scores. For the completion of the presentation or the note, I put set score here again. So the same thing is here. A set score is to compare the results of normal population. That is a fair method rather than just looking at the raw data and take the idea. So same example is here. So there are some even set score is a very good score to compare the students. There are some questions. There are some problems for the user. See, one thing is there are decimal points. So we don't like to deal with decimal points now. Assume if one's mark is lower than the mean value, here instead of 80, if there is 60, what happened? The value is minus 9.5. So we can have minus values for Z score. And if the value, mean value is round value, assume the you got the mean value of the data set as 69. And the student's normal mark is also 69. Then this value becomes 69 minus 69. 69 minus 69. So answer is 0. So there are 0 values also. There are 0 values, decimal values, negative values. So those are the problems for the user by using when using the Z scores. If there are problems, if one mathematician found Z score, then others found the problems in that, and then other mathematicians try to reduce those problems. That is the way to develop something. So to get rid of those questions, the mathematicians called McCall, Hull, they introduced several scales, 2 scales. And also there are some other scores, IQ scores, SAT scores, T scores, Z scores. Those are there are some more scores. If you browse the internet, you can have so many scores there. So among them, we discuss only about McCall's scale, or it is called T score, and Hull's scale. So McCall in 1939, he suggested a method to remove these negative and 0 values. This method also we can't get rid of decimal values, but we can get rid of 0 values and negative values. To do that, he introduced the constants. He suggests take the mean value as 50 and take the mean value as 50 and take the standard value as standard deviation as 10. That is what he told. So McCall's scale mark is denoted as XM. So consider we want to find the McCall scale mark of the mark X. There is unknown known mark X. So we have to find its McCall's mark. Now we are going to find the McCall's equation. So the standard score or Z score for McCall's for X mark can be written as X minus X bar divided by SD. This is X bar, not double dot, X bar. Divide SD. Then, if you want to find the Z score of McCall's scale mark, so you can write it Xm minus X bar is mean value, no? According to McCall, he introduced the mean value as 50 and the standard deviation value as 10. So again, Z can be written as Xm minus 50 divided by 10. And also, in the normal way, Z can be written as X minus X bar divided by SD. So both are equal. So we can consider this Xm minus 50 divided by 10 equal Z. And this is the normal equation. There is Xm minus 50 divided by 10 now. Divide by 10. To get rid of this divide by 10, you know this is simple mathematics. We have to multiply both sides by 10. Here, Xm minus 50, this division 10 comes here as multiplication of 10. So then, with Xm, there is minus 50. Minus 50 comes to this side as 50, plus 650. So McCall scale can be defined as Xm equal Z into 10 plus 50. Or T equal Z into 10 plus 50. T score or Z score. In the example, already we found the value for Z values for Suranga and Eranga. That is, Suranga's Z value is 0.57. Eranga's Z value is 0.72. So, to find the McCall's mark or T mark, the only thing is we have to substitute that value here. Instead of Z, we have to put that. See, 0.57 into 10, that becomes 5.7 plus 50, that is 55.7. Same to Eranga. So time is not enough to discuss about Hull score. That is similar to that. So we will discuss it in the next day. So I would like to take your attention to the question. Exercises. Here this is from percentile rank. So these are the types of questions you may have in the exam. Explain the necessity of converting the raw marks of norm reference assessment with examples. So here norm reference assessments we discuss in the first day. So at the exam one by one, we won't ask you what is norm reference assessment like that. So you may have questions like this. Explain the necessity of converting raw marks from norm reference assessments. Now you have to recall your knowledge on norm reference assessments. Can anyone recall what are the types of assessments? Can anyone remember? To answer this question, you have to have the idea of norm reference assessment. You did it in your presentations also, no? I know, as adult learners, when we do presentations, only that period we can have that idea or we can have that in our mind. Because we all are human beings, we deal with so many things. So that is the way. But we have to reduce that by answering such type of question. If you can't remember those things, so please go through. Now I told you it, we discussed it in the first session. So you can go through that and find the answers. Then try to, I don't want, next day we will discuss, but try to find the answer for this one. Explain the necessity of converting raw marks of norm reference assessment with examples. Try to find the answer. So if I tell you the answer, nothing there. You have to think, you have to remind. You have that understanding, but the thing is you have to remind those things. You have to have that practice. So then regarding Z scores, try to find the question. Yes, what is Z score? What are the features of it? How do you calculate it? So what is the Z score? Can anyone tell me? What is the Z score? That is the standard score. With the bulk, you may confuse. That's why I tell. What is the Z score? Z score is the standard score which we use to compare and combine the scores. That is based on normal probability distribution curve. And there it deals with standard deviation and the mean value. The features of it, yes, the features are that it deals with the standard deviation and the mean value. Then we can have the values lower than 1. So the Z score values are lower than 1. Most probably that is lower than 1. So there are some difficulties for the user. There may be 0 values, negative values, and several decimal points. Anyway, to calculate it, we have to use this equation. So write that equation. Z equal x minus x bar divided by SD. Then the next question, calculate the following according to the given data. There are 3 students, 3 subjects, science, maths, Sinhala, and also mean value and standard deviation values are given there. Now you can get the idea how to calculate Z score. So in the first Roman part, convert all raw marks into Z marks. So raw marks, there are 9 raw marks. 3 marks for science, 3 marks for mathematics, and 3 marks for Sinhala. If we take Rani to 60 marks for science, no? So then we have to convert this 60 mark into Z score. So the Z score equation is Z equal x minus x bar divided by SD. No? Then substitute 60 minus, according to science, the x bar is 50. 60 minus 50. So do it in your mind. 60 minus 50 becomes 10. 10 divided by 10, standard deviation 1. So first write Z score science marks of Z score value of Rani's science mark. equal x minus x bar divided by s and do that. Likewise, if we take Susima, she got 65. In mathematics, take mathematics 45. So 45 minus, regarding mathematics, mean value is 40. 45 minus 40, 5. 5 divided by 10, 0.5. So when we take Kamani, he took 50. She took 50. So 50 minus her mean value is 65. Here you can have negative value. Minus 15. Divide by 5, minus 3 there. So likewise, you have to calculate all Z scores for these 9 marks. So you have 9 Z scores here. Then take the addition of marks of each student. Again, we have to take the addition of each student. It means don't take the addition of downward, but horizontal addition. Rani's science marks, mathematics marks, and Sinhala marks. Take the addition of this. Another column you can add here. And then calculate the relevant Z score for subject of each student. And no need to calculate it again. We did it here. So take those Z score values and add all those Z values also in next column. It means Z value for science, Z value for mathematics, Z value for Sinhala or Rani. Then take the addition of them. By looking at the addition of row marks and looking at the addition of Z marks, then you have to compare and identify the clever student with reasons. So according to row marks, one will be the clever student. According to the Z score marks, one will be the clever student. You have to mention that. Then you have to give the reasons. But that is not fair by taking the decision with row marks. And then we have to, it is fair to go for Z score marks because it compares the student's performance with the same category. Like that, you have to clarify your answer. We need that ability from you. Understood. Are there any questions? This is one type of a question. I took this from question paper. So from next day, you have to answer. I hope the answers from you. Because you have to active even within this time period also. You may don't have time to deal with these things separately. You may don't have separate times. Even some of you can't stay here for 2 hours. No, there are some problems. So even if you are here lively in 10 minutes, you can have you have to take the best of it. Therefore, please try to remind those things. Okay, then those are the, we can wind up for today if you don't have questions. If you don't have, we can wind up from here. And thank you very much all.
you, madam.
Thank you.